According to the National Electrical Code, metal-clad cable must be properly grounded and bonded at both ends. MC cable should be connected to the panel and receptacle using grounding-type connectors. These connectors ensure a secure electrical connection between the cable and the equipment. Bonding is required to establish a continuous electrical path between all metallic components of the electrical system. In this case, the MC cable must be bonded at both ends. At the panel, bond the cable's bare copper ground wire to the panel's grounding bar. At the receptacle, bond the cable's bare copper ground wire to the receptacle box using a grounding screw or bonding lug. There is an exception. If the MC cable is enclosed in a continuous metal raceway that is grounded at both ends, bonding at each end of the MC cable is not required. The raised floor must provide sufficient clearance for the skirted cover to prevent damage to the MC cable. The MC cable must be properly supported throughout its run to prevent strain or damage. Follow the manufacturer's instructions for proper installation and bonding techniques. When installing metal-clad cable, it is crucial to adhere to the National Electrical Code requirements to ensure electrical safety and prevent potential hazards. Grounding and bonding are two fundamental aspects of electrical installations that play a vital role in protecting people and equipment from electrical shock and fire. Proper grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. Bonding, on the other hand, creates a low impedance path between all metallic parts of the electrical system, ensuring that they are at the same electrical potential. This prevents voltage differences that could cause electric shock. Now let us delve deeper into the specific requirements for grounding and bonding metal-clad cable according to the National Electrical Code. First, connection. Metal-clad cable should be connected to the panel and receptacle using grounding-type connectors. These connectors are specifically designed to provide a secure electrical connection between the cable and the equipment, ensuring a reliable grounding path. They typically feature a screw or clamp that firmly grips the metal jacket of the cable, establishing a low-resistance connection to the grounding system. Second, bonding. Bonding is required to establish a continuous electrical path between all metallic components of the electrical system. This includes the metal jacket of the metal-clad cable, the metal enclosures of the panel and receptacle, and any other metallic parts that could become energized in the event of a fault. In the case of metal-clad cable, bonding is required at both ends of the cable run. At the panel, the cable's bare copper ground wire should be bonded to the panel's grounding bar. This grounding bar is typically a metal strip or busbar that is connected to the building's grounding electrode system. The connection should be made using a listed connector or lug that is specifically designed for grounding purposes. At the receptacle, the cable's bare copper ground wire should be bonded to the receptacle box using a grounding screw or bonding lug. The receptacle box is typically a metal or plastic enclosure that houses the receptacle. The grounding screw or lug provides a point of connection for the ground wire, ensuring that the receptacle is properly grounded. There is an exception to the bonding requirement. If the metal-clad cable is enclosed in a continuous metal raceway that is grounded at both ends, bonding at each end of the metal-clad cable is not required. A metal raceway is a metallic enclosure, such as conduit or tubing, that provides physical protection and a grounding path for the conductors inside. If the raceway is properly grounded at both ends, it can serve as the primary grounding path for the metal-clad cable, eliminating the need for additional bonding connections. In addition to the grounding and bonding requirements, there are also some additional considerations to keep in mind when installing metal-clad cable. The raised floor must provide sufficient clearance for the skirted cover to prevent damage to the metal-clad cable. The skirted cover is a protective covering that is typically installed around the base of the panel to prevent accidental contact with live electrical parts. The metal-clad cable must be properly supported throughout its run to prevent strain or damage. This can be accomplished by using cable ties, straps, or other approved supports that are spaced at appropriate intervals. Follow the manufacturer's instructions for proper installation and bonding techniques. The manufacturer's instructions provide detailed information on the proper methods for installing and bonding the specific type of metal-clad cable being used. It is important to carefully read and follow these instructions to ensure safe and reliable installation. Now let's consider the 2014 National Electrical Code for specific grounding and bonding requirements related to metal-clad cable. Please note that electrical codes are subject to change, so it is always best to consult the latest edition of the National Electrical Code for the most up-to-date information. While I don't have access to specific tables or sections of the 2014 National Electrical Code, I can provide some general guidance based on common grounding and bonding practices. The National Electrical Code generally requires that all metal enclosures and equipment be grounded to provide a low impedance path for fault current. This helps to minimize the risk of electrical shock and fire. For metal-clad cable, this typically means bonding the cable's metal jacket to the equipment grounding conductor at both the source and load ends. This ensures that the metal jacket is at the same electrical potential as the grounding system. The size of the equipment grounding conductor must be sufficient to safely carry the fault current. The National Electrical Code provides tables that specify the minimum size of the equipment grounding conductor based on the size of the overcurrent protection device. Grounding electrodes are used to connect the grounding system to the earth. The National Electrical Code specifies the types of grounding electrodes that are permitted and the methods for installing them. Common grounding electrodes include ground rods, ground plates, and metal water pipes. Bonding jumpers are used to connect different parts of the grounding system together. The National Electrical Code specifies the size and installation requirements for bonding jumpers. Bonding jumpers are often used to connect metal enclosures, such as panel boards and junction boxes, to the grounding system. The National Electrical Code also addresses the grounding of specific types of equipment, such as receptacles, lighting fixtures, and appliances. These requirements vary depending on the type of equipment and the application. The integrity of grounding and bonding connections should be verified during installation and periodically throughout the life of the electrical system. This can be done using a multimeter or other testing equipment. Any loose or corroded connections should be repaired or replaced immediately. Now let's summarize the key points to remember when grounding and bonding metal-clad cable. Always use grounding type connectors to connect metal-clad cable to panels and receptacles. Bond the cable's bare copper ground wire to the panel's grounding bar and the receptacle box using a grounding screw or bonding lug. Ensure that the raised floor provides sufficient clearance for the skirted cover to prevent damage to the metal-clad cable. Properly support the metal-clad cable throughout its run to prevent strain or damage. Follow the manufacturer's instructions for proper installation and bonding techniques. Consult the latest edition of the National Electrical Code for the most up-to-date grounding and bonding requirements. By following these guidelines, you can ensure safe and reliable electrical installation with metal-clad cable. Proper grounding and bonding are essential for protecting people and equipment from electrical hazards. Remember, electrical work can be dangerous, so it is always best to consult with a qualified electrician if you have any questions or concerns. They have the knowledge, skills, and experience to ensure that your electrical installation is safe and compliant with all applicable codes and regulations. A continuous electrical path means that all metallic parts of the electrical system are connected together in a way that allows electricity to flow freely between them. This is important for safety because it ensures that any fault current will have a clear path back to the source, tripping the circuit breaker or fuse and energizing the circuit. If there is not a continuous electrical path, fault current may find an unintended path to ground, such as through a person's body, which can result in electric shock or electrocution. Bonding is the process of connecting all metallic parts of the electrical system together to create a continuous electrical path. This is typically done by using bonding jumpers, which are short lengths of wire that are used to connect metal enclosures, raceways, and other metallic components. The size of the bonding jumpers must be sufficient to carry the fault current. Grounding is the process of connecting the electrical system to the earth. This is typically done by using a grounding electrode, such as a ground rod or a metal water pipe, which is buried in the ground. The grounding electrode provides a path for fault current to flow to the earth, which helps to protect people and equipment from electrical shock and fire. The National Electrical Code contains detailed requirements for grounding and bonding electrical systems. These requirements are designed to ensure that electrical systems are safe and reliable. It is important to consult the National Electrical Code when designing and installing electrical systems to ensure that they meet all applicable requirements. Here are some additional details on how to properly ground and bond metal-clad cable. When connecting metal-clad cable to a panel or a receptacle, it is important to use a grounding type connector that is specifically designed for use with metal-clad cable. These connectors typically have a screw or clamp that is used to connect the metal jacket of the cable to the grounding terminal of the panel or receptacle. The bare copper ground wire in the metal-clad cable should be connected to the grounding bar in the panel or to the grounding screw in the receptacle box. This will provide a direct path for fault current to flow back to the source. If the metal-clad cable is enclosed in a metal raceway, the raceway must also be grounded. This can be done by connecting the raceway to the grounding bar in the panel or to a grounding electrode. It is important to ensure that all grounding and bonding connections are tight and secure. Loose or corroded connections can create a higher resistance path for fault current, which can increase the risk of electric shock or fire. Here are some additional safety tips to keep in mind when working with metal-clad cable. Always disconnect the power before working on any electrical circuit. Use insulated tools when working with electrical wiring. Wear safety glasses to protect your eyes from flying debris. If you are not comfortable working with electrical wiring, hire a qualified electrician.